Question 2. Separate samples of sodium carbonate and sodium hydrogen carbonate react with hydrochloric acid to produce the same product as shown in this table 2.1. So in this table 2.1, there are two reactions. So the carbonate with HCl form the salt H2O CO2. Sodium hydrogen carbonate react with HCl, also form the same products as is mentioned. And the enthalpies for this reaction 1 and 2, they are different. Delta H1, later we need to find it. Delta H2 already given, which is endothermic, positive 27.2 kJ per mole. Part A, complete the reaction pathway diagram in figure 2.1. For the reaction 2, label the diagram to show the enthalpy change and the activation energy, EA. Whenever you see reaction pathway diagram, means you need to draw something like this with the EA. Because it's already told you this is endothermic reaction, so you need to make sure the product is higher energy level than the reactant. So means in this figure 2.1, you need to draw one line which is higher than the reactant here. After that, you just put the products on top of that and you try to draw a curve, right, from these reactants to the product. Make sure there is a EA here, right? So from this line, dotted line, pointing up to the peak maximum, so this is the activation energy for the reaction. And after that, you need to complete the diagram with the delta H2. So you just put another arrow from the line to the products here. So then you put delta H2 and you put the values. That's all. Part B. The value for the delta H1 is determined by experiment using the following method. Okay, so there are a few steps. Okay, start with the acid solution. 50 cm cube of 2 mole per dm cube HCl added to the polystyrene cup. Initial temperature recorded 19.6 degrees C. 0.04 mole of the sodium carbonate added to the mixture and is stirred. All the solids, means the sodium carbonate, disappear and a colorless solution is produced. The last one is very important because this statement already told us, without calculation, already told us the limiting reagent is the sodium carbonate. Actually, you no need to really calculate, because this statement already told us that the solid, means the sodium carbonate, it must be limiting reagent because it's disappeared. If you want to confirm whether this is the limiting reagent or not, yes, you can. You just calculate the moles of the acid, MV over 1000, you get 0.1. And the moles of sodium carbonate used is 0.04. So let's get back to this equation 1. So it's 1 mole react with 2 moles, right? So therefore the acid is still in excess. Okay. So after that, the maximum temperature recorded is 26.2 degrees C. Okay, later we need to calculate the delta H1 using all this information. Okay, let's move on to the part 1. Describe one other observation that show the reaction is complete. Just now already told us that the solid disappeared. Other than solid disappear, what is another observations that you can get? Because From this equation, we know that one of the product is CO2, so it will form gas, means it will be effervescence. Right? And if, let's say, we want to get or describe the observation shows the reaction is complete, so we cannot just say effervescent. In order to know the reaction is complete, we must say that effervescence is not there, right? So means effervescence stops. When there is no effervescence, means the reaction is complete. That's what you need to write. Part 2. Calculates the value of delta H1 in kilojoule per mole. This one is very easy. First, you need to calculate the heat that involved. So use Q equal to MC delta T. M is the mass of the solution, which is 50. You can check back this the statement, because it's 50 cm cube used, right? The solution. So we put 50. For the C is the specific heat capacity of water. So you just put 4.18. You can get from the table in the question. Okay, delta T is we use the final temperatures minus the initial temperature. Okay, after that you get the Q in joule, 1379.4 joule. Substitute the Q into the delta H expression here. So delta H equal to negative Q over 1000 N. Over 1000 because we need to convert the joule to kilojoule, right? So joule, when it's over 1000, is kilojoule. N is the mole of limiting reagent. Okay, so therefore now you can substitute everything into the delta H. So Q already obtained just now. Substitute the 1379.4 over 1000 times 0.04. This is the moles of the limiting reagent, the sodium carbonate. So you get negative 34.5 kilojoule per mole. Okay, this is the delta H1. Part 3. Thermal decomposition occurs when the sodium hydrogen carbonate is heated, which is the reaction 3 now. So it will form sodium carbonate, H2O and CO2. Calculates the enthalpy change for this reaction, which is the delta HR, using the data in the 2.1 just now and the delta H1 that obtained in the part 2. Okay, if you cannot really get it, so you use this one, right? Okay, now if you really want to make sure you have or you get the correct calculation, so to construct the Hess cycle, it will help a lot. So first, how to construct the Hess cycle? Then you need to start from the reactions tree that given just now here, this one. So this is the delta HR you need to calculate. And the products is sodium carbonate, H2O and CO2. Okay, but you need to link this with the table 2.1 enthalpy. Okay, let's get back to the table 2.1 again. Okay, in the table 2.1, as you can see, there are two reactions, right? Sodium carbonate with acid and the sodium hydrogen carbonate with acid from the same products. So we can use these two now for the Hess cycle. As you can see, the products for these two reactions actually same. The sodium chloride, H2O and CO2. So therefore, we can use these products to link the reactants and product just now. Okay, let's get back to the Hess cycle. Okay, so this one again is the delta HR that you need to calculate, and we can link the reactants and the products together using the sodium chloride, H2O and CO2. Okay, so look carefully. When we have this reaction, let's say now we add the hydrochloric acid to the sodium hydrogen carbonate. So it will form the sodium chloride, H2O and CO2. So this one is the delta H2, the second reaction. And we need to add the same amount of acid to the right hand side. So now the sodium carbonate reacts with acid, form the salt, water and CO2. So this one is delta H1. So means we need to use the delta H1 and delta H2 to get this Hess cycle. Now, the quantity that involved is important, because in this equation, as you can see, 2 moles of the sodium hydrogen carbonate is used up. So therefore, the delta H2 must times 2. And in this part, the sodium carbonate that used up is only 1 mole. So we just use delta H1. Okay, complete the Hess cycle. Delta HR plus delta H1 is equal to 2 times of the delta H2, which is this one. So this is the equations that obtained from the Hess cycle. Rearrange, because we want to get the delta HR. So delta HR therefore is 2 times of delta H2 minus delta H1. So substitute the values from this the table, and this is the one that from the part 2. So you get positive 88.9 kilojoule per mole. Part C. Z is the salt that contains period 4 elements from group 2. Period 4 elements group 2, very clear, is calcium. Now, when Z is heated brown gas form, so means we are quite sure the Z is the calcium nitrate, and after that you need to write the equations for the reaction. Calcium nitrate undergo decomposition will form the calcium oxide, brown gas, which is the NO2, and oxygen. So the ratio is 2:2:4:1, or you can put 1:1:2 half. That's all. Thank you.